things you need to know about perpendicular bisectors and angle bisectors. In a perpendicular bisector, that's a line that divides a segment into two equal pieces and it's perpendicular. The perpendicular bisector theorem says that any point on this line, like this one here, or this one, or this one, or this one, they're all equidistant from the two endpoints, A and B. Okay, so if you have a line, you can see that it's bisected because it divides it into two equal pieces. You can tell it's perpendicular. That this point here, the distance from here to B is the same as the distance from here to A. This point is same distance to B, same distance to A. This blue line, same distance, same distance. So basically what we're making is all these series of isosceles triangles because the distance from any point on this line is the same to both endpoints. Okay, and we call that collection of points, so this point, this point, this point, this point, we call that collection of points a locus. A locus is a set of points that satisfy a given condition. Okay, and the converse is also true. If this locus of points are all equidistant from the endpoints, then all those points are on a perpendicular bisector. Okay, so if we're going to put that into a problem, here we've got a perpendicular bisector because from M to the line is the same as from the line to L, and it's perpendicular. So if the distance from N to L is 2.6, the distance from N to M is also 2.6. Okay, same thing here. We can tell that A to B and A to C are both 38, so that makes this a perpendicular bisector. It makes DA a perpendicular bisector. So if it's a bisector, if this is 12, then this is 12. Okay? And if, again, it's a perpendicular bisector because it's perpendicular and it bisects the bottom part here, that means these two distances are equal. So 3x plus 9 is going to be equal to 7x minus 17, or 4x is equal to 26. So x is equal to 6.5. Right? Now, if I'm going to, for the last one, to write an equation of a line that's perpendicular, that is a perpendicular bisector of a segment whose endpoints are at -4, 7, -7, and 0, 1. Okay, so there's two things I need. I need to write the equation of a line, I need a slope, and I need a point on that line, and I could use point-slope form. So to find a point on my, like if here's my line, like negative, so this could be -4, I know it's not on a graph, but -4, -7, and 0, 1. The midpoint isn't that going to be on my perpendicular bisector? The midpoint between the two because it bisects that line. So the midpoint is going to be -4 plus 0 divided by 2 and -7 plus 1 divided by 2. So that point right there is going to be -4 divided by 2, -2, -6 divided by 2, -3. So this point is at -2, 3. And if it's perpendicular, then all I have to do is find the slope of this green line here and use the opposite reciprocal. So the slope would be y2 minus y1, -7 minus 1, over -4 minus 0. So that's -8 over -4, or 2. So a perpendicular line would be -1/2. So if I put these two things together in point-slope form, the equation would be y minus y1, which is -3, equals m times x minus x1. So I'm using, this is my m, and this is my x1, y1, and I'm plugging into that equation. Okay? Right, so that's perpendicular bisector. Angle angle bisector kind of works the same way. The bisector, a line that bisects an angle is made up of points that are equidistant from each side of the angle. And they have to be the same angle, like we always draw them right angles, because if you think about it from that point over here, that's not going to be the same distance. So when we're talking about having to be the same distance, we're saying that it's the same perpendicular to both sides. It's the same distance. So from this point to here is the same distance as from that point to here. Or from this point to there is the same distance as from that point to there. Okay? And that makes two congruent angles. Okay? The angle bisector theorem, so if a point is on the bisector, it's equidistant to the sides. The converse is also true. If you have a locus of points that are equidistant from the sides, then it's a bisector. All right? So we can go both ways. We can say, okay, we know this is an angle AC is an angle bisector because these two angles are equal. So if this is 7.2, then this is 7.2. Okay? We know that EFG is 50. The whole thing is 50 degrees. We know this is an angle bisector because this distance is the same as that distance, so each angle would have to be 25. And the last one, again, we know that NL is an angle bisector because it's the same distance from L to K and L to M. So these two are equal. So to figure it out, I'd say 3A plus 20 is equal to 2A plus 26. So I subtract 2A from both sides and I get A. I subtract 20 from both sides and I get 6. So A equals 6. Okay? Okay, part 2 is going to be to actually construct an angle bisector and a perpendicular bisector. To construct an angle bisector, the first thing you do is take your compass, put the pointy end right on the vertex of the angle, open it up, any amount, and make an arc. Okay? Then move your pointy end to that spot, because basically we're just saying, okay, it's the same distance down the side of the angle, and make an arc from there. And again, keeping it open the same amount, we're going to make another arc here. Okay? Then we're going to connect those sides, or those 2 points, okay? The vertex and that point there, and that is going to be an angle bisector, okay? And we will have time to practice that in class tomorrow. All right? The second one is a perpendicular bisector. So we're going to have to find the midpoint of this segment, and we're going to need to draw a line, and it takes 2 points to draw a line. So the way you do that is you open your compass more than halfway open across this line. Okay, this is going to be a hard one. So this is more than halfway, and then I make a big giant arc. Okay, now leaving the compass open the exact same amount, I put the pointy end on this end. Okay, I flip it. Let's see, I can't remember how to flip it. Okay, and I make another arc like that. Okay, so the distance from here to here is the same as the distance from this point to here is the same as the distance from that point to there, because we had the compass open the same amount. And we just learned that that means this is a locus of points that represent the angle bisector, or to represent the bisector, perpendicular bisector of an angle. So I connect my point here and my point here, and that makes a perpendicular bisector. And you can do that on a triangle. Like if I wanted to think of this triangle as 3 different angles, I could bisect all 3 of those angles, and they would meet at a point in the middle. So we will do that tomorrow in class. We will practice drawing perpendicular bisector of all 3 sides of this triangle and an angle bisector of all 3 angles of this triangle.